Hello, welcome back to LIVENODING. In this episode, we're going to take a look at the new nodes in SphereChalk. It's called a set mesh attribute. So this set mesh attribute is not too obvious. If you look at it at a glance, it's expecting some kind of object, and we can basically inject any value attributes into an object using this node. So let's create something, for example, like an icosphere. And we're gonna mesh viewer this icosphere. So we have this icosphere, and we can monitor this object's points attributes. Currently, it only has like positions. If we plug this into this guy, and we create like a SV, suddenly we have new attributes. It's called SV. This is actually in relations to geometry nodes. So if we create geometry nodes and create something like attribute fill, this is very similar. Let's try this. Just call it GN. So suddenly we have this value that we can fill. Same case over here. So let's save this very quickly. This is mesh custom. So a single point can have a value that can be injected using SphereChalk. Of course, inside geometry nodes you can do the same, and you can easily use like attribute randomize. So you can randomize a value, like in this case GN. We can replace with random value, or we can just add or subtract or multiply. Same thing with SV here. You can use random number, and the size should match the icosphere, but I just gonna plug this. You can see random value is being generated and injected into this geometry. We also have like attribute transfer, which I'm not gonna use. But this one, this guy can also transfer value based on nearest points or nearest face, which is quite interesting. So that's based on the distance. So let's back to this and how we can inject value, because random number is cool, but sometimes we don't want just random numbers. We want to have like something that's more like noise. So we can do that very easily. This icosphere has vertices that we can pass into the vector noise, and as the output, we can use a scalar value that we can plug it into there. So now we have noise value being passed into this icosphere. So which means if we create like a donut, for example, like a pose. Now I'm gonna try to replicate the donuts for the icosphere. I'm gonna hide the donuts. I will use it as instancing. For the point instance, I will be using the donuts. The icosphere, the original icosphere, disappears because we replace the points with donuts. As for the donut itself, we can scale the point using attributes from GN or SV. So that's the attribute from SV. So let's change the appearance of the donuts. And look at this. The vector noise now is affecting the scale of the donuts instance. So we can animate the donuts in this fashion. So it's really cool. So now instead of icosphere, let's try just replace it with something else, like grid, for example, plane. I believe we can just delete this, recreate a new object. So we have grid now, and use the points of the grid to generate vector vertices. So now we should have just points with SV attributes, which we can assign geometry nodes and also get the original geometry nodes. Now we have this ocean of donuts that we can animate this way. So you can see what's happening. It's a vector noise being offset over the donuts. Okay, so I haven't tested this, but I think you can kind of daisy chain this. I'm gonna use like SV2, for example. That's the name of the attributes. Okay, we cannot see because we are looking at the evaluated points attribute. Let's take a look at original. Now we have SV and SV2. For the points domain, we can also use other things like maybe vector. Okay, this is actually giving you ability to look at the vector value. So you create random vectors. The count can come from this guy over here, list length. So we get the length of these points, plug this into the count. We have now random value. You can see. And so we can rotate the point based on that value. Okay, so now this donuts is random. Okay, so I think if we delete sphere chalk, the custom value will actually stay with it. I haven't tried. What else I should try? Okay, so let's say if we like this setup, I make this route. I can replace it with vector P field, like this there. So now we have this grid of donuts that we can adjust. We can randomize, and we can animate. Okay, so I think it's really cool. Actually, you can try baking it as Alembic, but I think if I delete the stretch of nodes, what's being left behind is really just like a point cloud with custom attributes. So we don't need the stretch of nodes anymore, but we lost the ability to modify that. However, we can still modify it using attribute randomizer. And I think it should work, but it doesn't. Maybe I think with the custom attribute we cannot really do anything. We can go back and take a look. Okay, there's a GN value here. That maybe we can use. For example, use this GN for point scale. maybe we can modify it from here. Oh yeah, so apparently we can modify the value this way. So we just need to ensure that we put something, we put these nodes before the processing and before the instancing. All right, so that's basically what I want to show you in this first look. Basically, so we can easily inject any value into an object or geometry and then use that value inside geometry nodes. So let's reopen. Okay, cool, still works. Save as new file. Occasionally, it's a if it stopped working, you need to just refresh the node. The cool thing about this setup, of course, everything is procedural, so you can just replace the donuts with anything. For example, randomize this, and if we, for example, we scale the donuts that way, this guy can be also remeshed. Pretty cool. Yeah, see, this is the custom attribute that we injected into the geometry. Now it's working inside geometry nodes. All right, so hopefully you find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.